Now here we have a very standard question, and I'll tell you the method which you should use in these type of questions so that you never get the wrong answer. 300 gram of ice at minus 20 degrees Celsius is immersed in a calorimeter containing 200 gram of water at 8 degrees Celsius. We need to find out the temperature of the final system at thermal equilibrium and the final composition of the mixture at equilibrium. So in these type of questions, when two substances are mixed, or when 2-3 liquids are mixed, or when when substances are in 2-3 different states, so what you do always is that, especially in these type of questions involving ice and water, always bring all the substances to one common state. So let us choose any state. You can choose any random state. Let us take the case of, let us choose the state to be ice at 0 degrees Celsius. This is our parent state in which you bring everything. So what are the things we have? We have 300 gram of ice at minus 20 degrees Celsius, and we also have 200 gram of water at 8 degrees Celsius. So you bring both these things to this state and you check as to how much heat is involved in this process. So first let us take the case of 300 gram of ice at minus 20 degrees Celsius. To bring it to ice at 0 degrees Celsius, 300 into specific heat of ice, that is 0.5 into 20, that is equal to the amount of heat has to be given. So we write it as plus. This is equal to plus 3000 calories. So we write this as, we keep a stock here, plus 3000 calories. That is an external heat. Let us assume this as the external heat. This is plus 3000 calories. Now we bring 200 gram of water at 8 degrees Celsius to 200 gram of ice at 0 degrees Celsius. So first let us bring this to, always bring this to the common point of state change, that is 200 gram of water at 0 degrees Celsius. So in this process, heat given to the system will be negative because heat is released from the system. The heat released is equal to minus of 200 into specific heat of water, that is 1, into delta T, that is 8, that is equal to minus 1600 calories. Now we convert this to 200 gram of ice at 0 degrees Celsius. So again heat is released from the system, therefore heat given to the system, let us write this as here minus 1600 already. Now again the amount of heat given to the system in this process will be equal to 2 minus of 200 into the latent heat of fusion of ice, that is 80, that is equal to minus 16,000, that is minus 16,000 calories. So the total heat given to the system externally is equal to this much in bringing the whole system from this to this. So this comes out to be minus 14,600 calories. But really what has happened is that no external heat has been given to the system or no external heat has come out of the system. So we have assumed that this much amount of heat is being released from the system. So we give this much amount of heat to the final system, that is 500 gram of ice at 0 degrees Celsius. Our system now is 500 gram of ice at 0 degrees Celsius and we have to give this much heat to this system. So let us check how much amount of ice is melted with this much amount of heat given. This is equal to 80 into m. So m comes out to be equal to 1460 upon 8, that is equal to 182.5 grams. But the mass of ice which we already had was 500 grams. So final system becomes 182.5 gram of water at 0 degrees Celsius plus 317.5 gram of ice at 0 degrees Celsius. So we get a final answer that the final temperature of the system, since ice and water are coexisting together, whenever ice and water are coexisting together, the temperature of the system will always be 0 degrees Celsius, and the composition of the final mixture is, the final mixture has 182.5 grams of water and 317.5 grams of ice. So what we learned from this question is that there is a standard way. I'll repeat the way again. Bring all these substances to one common state that you have chosen. during that process, find out the net external heat given to the system. This may come out to be positive or negative also. If this would have come out to be positive, then we would have taken that much amount of heat from the final system. But since this came out to be negative, that means the external heat given to the system was, virtually the external heat given to the system was minus 14,600 calories. But since no such heat is given, therefore we give 14,600 calories of heat to the system to convert this much some amount of ice to water to get the final answer.